Hello, good morning, math magicians. Yep, that's you. I am your fearless leader, Mr. Ludd. I'm going to take you through a lesson on the area of a segment, which is in a circle. Oh, that's exciting. I'm not going to this website. You can if you want. Okay, so this is what a segment looks like. What? It's the area between a chord and the edge of the circle, right? So could it be a half a circle? Potentially, right? That'd be really easy to calculate. Pi r squared, divide by 2. Done. Well, it's not so easy if that chord is not the diameter. So I want to sketch for you a friend that we know the area of very well. That's a triangle. Oh, oh. So the area of that blue space would technically be the area of a sector, which we talked about yesterday. Area of a sector, reminder, would be central angle over 360 times pi r squared. And we're going to take away from it the area of a triangle. The area of a triangle, which, of course, we're familiar with that formula as well. That'd be 1/2 base times height. So what are the things that I need to know? Well, I need to know r. I need to know n. And over near here, I need to know the base and the height. Now, will there potentially be any overlap? Yeah, possibly, between what variable represents what and what value that is. But here, I know that this is definitely r. Right? I know that this angle inside here, that's n. And then it comes to that triangle. Like if I were to pull that triangle out, right? If I pulled that triangle out, this length right here, which would be the chord right here, that'd be the base. And the distance from here to here, that'd be the height. Okay, so that's where you're going to identify your 4 variables. Let's go to an example. I think the next page talks about that. Okay, so here we go. Sweet. I don't like the way that that 24 doesn't show up real well. You probably can't see it very well in the back, so I'm going to change the color of that. But that would be our base length. Okay, so let's take a stab at this. So the area of a sector minus the area of a triangle will give me the area of the segment. All right, so the central angle n, what is it? 120, right? It's the same as the arc measure that it intercepts. Okay, so if that's 120, then our central angle is 120. We're going to take pi times radius. What is the radius here? 13, right? And then I'm going to take the area of the triangle, which would be 1/2 the base times the height. My base and height are 24 and 5. Okay, so let's do some cleaning up here. What is 120 over 360 equivalent to? 1 over 3. Oh, thank you in the back. Thank you. Times 169 pi. 13 times 13 is 169. 169 is not a multiple of 3. It's sad, I know. You're like, shoot, that would have been so nice. Okay, so I'm going to leave this as 169 pi over 3. That's going to be the area of the sector. Now, the area of the triangle will be much easier to calculate. 1/2 of 24 times 5 is the same as 12 times 5, because 1/2 of 24 is 12. So that'll be 60. Now, the temptation of most children out there is to go further here. And I actually want you to be done right here. This would be the area of the sector. Excuse me, segment. Okay, that would be the area of the segment. Okay, so let's think about this example here. Ooh. Now what would this segment, right, be composed of? I've got what inside the blue space? A triangle. And what else? What would this space right here be classified as? What could I classify that space as? What was yesterday's lesson called? Area of sectors, right? Isn't that just a sector? Right? That's a sector. And what would this space be? No. Triangle. So in this case, I'm not going to subtract. What? You're not. No. I'm going to take, to find the area of this segment, I'm going to take the area of that sector and the area of that triangle, and what am I going to do? I'm going to add them. Weird. Okay, so let's do it. Area of the sector. What is the central angle of that sector? It's in red. It looks like 240. So 240 over 360. What's the radius? I'm asking you because I don't have my glasses today. 13, cool. And I'm going to add the triangle, which is 1/2. Oh, the dimensions are the same. Okay, that was cool. That was nice of me. Wait, we already did this, right? We have these numbers. We did this, except now we're not subtracting, right? We're just adding. So this would be 169 pi over, was it 3? Uh-oh, hold on. No, we do need to do some more calculation because this used to be 120 over 360. 120 over 360 was 1/3. 240 over 360 is 2/3. You bet. We'll see you tomorrow. Okay, so that'd be 169 times 2/3 times pi. Okay, so let's work our way through this. 1/2 of 24 is 12. 12 times 5 is 60. Let's do a little bit here. 169 was not divisible by 3. So 169 times 2 will probably not be divisible by 3. 169 times 2, is that 336? 338, sorry. So I get 338 pi over 3 plus 60. I'll just write that over here. Okay, so that's a weird one, right? But it's still a segment, right? A segment is just formed by the area between a chord and the edge of the circle. So segments are interesting in that way. When would I add and when would I be subtracting? If the area I'm seeking is less than half the circle, right? If the area I'm seeking, is less than half, I'm going to subtract. If the area, is more than half, it'll be adding. Cool. Like, subscribe, comment below. If you're the 100th subscriber to my channel, I'll get you a Math Magic t-shirt of your choice. Huh? Buy the merchandise? I give it away free. I don't need money. I'm still recording, aren't I? That's right. 100th subscriber, you'll get 3 stickers. Probably one that has a kid that has hair that looks like gravy. And half birthday for a couple of our individual students is coming up soon. My half birthday just passed. I did not celebrate it. But I will be celebrating my birthday on the first day off of school. Like, subscribe, comment below. Can't say that enough. Enjoy your afternoon, and maybe next lesson we'll have a surprise winner of some Mr. Ludd artwork. Pure.